Good morning, everyone. Today we'll be dealing with session 4 of highway engineering. In this session, we'll mainly deal with highway planning, planning surveys, master plan, saturation system, problems on saturation system, third 20-year plan, and MCQs. Now, what is the necessity of highway planning? Planning is considered as a prerequisite before attempting any development program. In engineering works, planning is a basic requirement for any new project or expansion. Planning is of great importance when funds available are limited, whereas total requirement is much higher. The objective of highway planning are to plan road network for efficient and safe traffic operation at minimum cost, to arrive at road system having maximum utility, to fix up-to-date priorities for development of road, to plan for future improvement of roads, to work out financing system. Planning surveys. The studied carried out are economic studies, financial studies, traffic or road use studies, and engineering studies. So to plan the survey, these are the main studies carried out. So first, economic studies. The data collected in economic studies are distribution of population in each locality, village, and town. Next, trend of growth of population, agriculture and industrial products, trend and development of agriculture and industry, per capita income. Next studies are financial studies. The data collected in this study includes source of income and revenue, living standard of people, toll taxes, vehicle registration and fines. Then future trend of finance. Next study is traffic or road use studies. The data collected in this study include traffic volume of vehicles per day, annual average daily and peak hour traffic, origin and destination studies, traffic flow pattern, accident and their cost analysis and causes of accidents, future trend in growth of traffic volume, next growth of passenger trips and choice of modes. Next, engineering studies. The data collected in this study includes topographic details, soil surveys, location and classification of existing roads, road life studies, special problems in drainage, construction and maintenance. Next is master plan. So master plan is the final road development plan for an area under the study. In master plan, different possible networks of new roads, improvement of existing roads are proposed. Each proposal has population and production of each locality, traffic flow, topography of existing and possible changes in futures. Alternate proposals of road systems are compared and best is selected. Best road system out of alternate proposal can be calculated by using saturation system. Next, what is saturation system? So the optimum road length is calculated for an area based on maximum utility per unit length of road. Saturation system is also called as maximum utility system. The utility per unit length of road is obtained based on population served by the road network and productivity served by the network. The productivity can be further subdivided as agriculture products and industrial products. Now, coming to steps, first we'll calculate population units. Area under consideration may consist of villages, towns with different population. So we should group the population into different ranges and assign some reasonable value of utility units served for each population range. For example, we can take, so the population range between 1000 to 2000 may be grouped as 1 unit. Similarly, villages with population ranges can be given different utility units. So we can say that population less than 500 utility unit can be 0.25. For population range of 501 to 1000 utility unit will be zero point 0.5. So population range from 1001 to 2000 utility unit will be equal to 1. So for population range 2001 to 5000, utility unit will be 2. So now distribution of population groups, number of towns and villages with different population ranges served by each road is found and converted into utility served by each road system. Thus, total number of units based on population can be obtained for each proposed road. Similarly, for productivity units, the total agriculture and industrial products served by each road system is worked out. Productivity served is assigned appropriate value of utility unit per unit weight. Example, 1000 tons of agricultural products will be equal to 1 unit. Similarly, industrial products may be assigned utility per unit. So total productivity units served by each system is estimated as population plus productivity. So utility per unit length of road served by each road system is given by adding population units and productivity units. Total units scored are divided by total road length of each system. We'll be getting utility rate per unit length of road. Different road systems have different layout and length. So we'll get different utility rate per unit length. The proposal which gives maximum utility per unit length may be chosen as the final road system with optimum road length. So for example, by the problem we can see. So work out the utility per unit length for each of the systems and indicate which of the plants yield the maximum utility based on saturation system. Now in this problem, we have four proposals P, Q, R and S. So four roads have different road lengths. And in each proposal, there are different population ranges. So starting from 1001 to less than 10,000. And there are different agriculture and industrial products. Now, depending upon the population ranges, you can assume the utility units. Now for 1001 to 2000, we are assuming the utility unit of 0.25. For 2001 to 5000, utility unit is 0.5. So productivity unit for 1000 tons he has given as 1. Okay, so this is the data given. So four road proposal we have with different road lengths. Now, depending upon different population ranges, you are converting the population ranges to 1 unit and you are calculating what is the total productivity units or population units in the particular proposed road. Now, so for example, I'll take for system 1. So road length is 300 meter. population unit for 1000 to 2000, they have given us 160. So 160 multiplied by utility unit, that is 0.25. You'll be getting 40. In the same manner, see, for population range from 1001 to 2000, you have 160. Similarly, for 2001 to 5000, you have 80. So 80 into 0.5. Similarly, for 5001 to 10,000, you have 30 into 1. Okay. Now, so total population units will be 160 into 0.25 plus 80 into zero point 0.5 plus 30 into 1 plus 6 into 2.5. So total you will be getting as 125 units. Similarly, productivity utility units will be equal to total agriculture and industrial products. So here we have combined agriculture and industrial. In the problem he has given. So agriculture and industrial product in terms of 1000 tons. So it is 270. Okay. So 200 into 1, you will be getting 200. So total utility units will be equal to population units plus productivity units. That will be equal to 125. You have already calculated here, plus 200. That will be equal to 325 units. Now, utility unit per unit length. So, utility unit per unit length will be equal to total utility units by total length of road. That will be equal to 325 divided by total length, it is 300. You will be getting 1.083. In the similar manner, you are calculating for all the roads. So for road Q, you have 200 into utility unit, 900 into zero point 0.5 plus 60 into 1, 8 into 2.5. Then agriculture and production, it is 270 into 1. Total you will be getting 615 divided by total road length, it is 400. You will be getting 1.537. Similarly for R, if you multiply it by utility units, you will be getting 727 divided by total road length, it is 500. You will be getting 1.45. So for similarly for S also you will be getting 1.39. Now, so these are the utility units for different roads. Now, depending upon this, you can say, so which is highest priority? You can classify. This 1.537 will be in the priority 1, that is road Q. Then priority 2 will be road R, priority 3 will be road S, and priority 4 will be road P. So this calculation you can do by multiplying like this, or you can also do in by tabular form. In the tabular form also you can calculate, you will be getting the priorities. So next one more problem we can move. So here there are 3 roads A, B, C in a district in 5-year plan. So work out the order of priority for facing the plan program by maximum utility principle. Utility of 1 for population range 2000 to 5000. Assume any data if required than the following. Now here what they have given? 3 roads they have given, and the length of the 3 roads are like this. And they have given utility for this range 2000 to 5000. He has given the utility range. Okay. Now what we will do? We first will assume the utility units. Now utility units for village served with population less than 2000, I'll assume as 0.5. 2000 to 5000 he has given already in the problem. You can take as 1. Similarly, for greater than 5000 you can assume as 2. For agriculture products you can assume as 1, and for industrial products you can assume as 10. Now For a particular road, if you take, so you have units here. So for this ranges, for all these values, you are multiplying with utility factors. Okay. Now, so for road, if you take 10 into, for this is a population range less than 2000. So 10 into 0.5 plus 8 into 1 plus 3 into 2. So this is all, these three are for population. Similarly for agriculture and industry. So 15 you have, so 15 into 1, 1.2 into 10. So total you will be having 46 divided by road length, that is 50. So you will be getting 3.07. Similarly for B you are getting as 2 and for C you are getting as 2.89. Now seeing this value, I can prioritize. Road A has to be faced in first priority, road C has to be faced in second priority, and road B is faced in third priority. Okay. So next topic is third 20-year road development plan. So this plan is also called as Lucknow plan, and it was developed in 1984, and the year is from 1981 to 2000. So here in this third 20 plan, basically the road was divided into three classifications: primary, secondary and tertiary classification. Now here the main concentration was given for improvement of transportation facilities in villages, towns and small cities. And the target road density was 82 km per 100 square kilometer area. NH should be expanded to form 100 kilometer square grid, so that no part of country is 50 kilometer away from national highways. Then expressways should be constructed along major traffic corridors. Then roads should be built in less industrialized areas to attract growth of industries. Towns more than 5,000 should be connected by MDR, and villages with population 1,000 to 1,500 by ODR. Long-term master plans should be prepared at various levels, taluk, district, state, to provide maximum utility. Then existing roads to be improved for their geometry, surface conditions, defects, strengthening, etc. to save vehicle operating cost and conservation of energy, preservation of environmental quality and improvement in road safety. Next, so the road length can be determined by these formulas. So for primary road system, that is expressways and national highways, length of national highway in a country will be equal to total area of the country divided by 50. In secondary road system, we have state highways and MDR. So length of state highway will be equal to 62.5 into number of towns in the state minus length of national highway. Or it can also be calculated as length of state highway will be equal to area in square kilometer divided by 25. So by both the formulas you are calculating, and whichever gives the maximum value, that you are assuming as length of state highway. Then next, length of MDR. So length of MDR will be equal to area of state divided by 12.5. Or you can also calculate by length of MDR will be equal to 90 into number of towns in the state. So here also by both the formulas you are calculating whichever gives the maximum value, that you are assuming as length of MDR. Okay. So this completes your and then we'll be going to MCQs. So here the accident cost analysis is estimated by conducting traffic survey. Then next, determination of optimum road length is based on saturation system. The final step after fixing the optimum road length is phasing. Planning is based on factual data and analysis. Third 20-year plan is also called as Lucknow plan. Okay. So this completes your section 4. Okay. Thank you.